Okay, Algebra 2. Yesterday I sent a couple of you guys around, or the two classes around, to gather data from students for height. And we did 5 boys and 5 girls from each class 7 through 12. So that is 60 total people. Okay, and so what I did was I took those tables and I crunched some numbers for you. Okay, so this was the list of all of the students together. I just put them, like side by side so you can see this table. And then what I did is I found the average height and the standard deviation for the height. So if you can't see that very well, this is 66.5, and then this one was 4.0 for a standard deviation. Okay, we'll just go to 1 decimal place on each one of those. But then I went ahead and separated them out into 2 groups. So I did the boys' data and I did the girls' data. So if you need the average and the standard deviation for those, the average height for boys was 68.9. 68.9, I'll write that closer. And then 3.97 would round to 4.0 if we go to 1 decimal place. So standard deviation of 4.0 there as well. And then for the girls, the average height was 64 point, we'll round it to 2. And the standard deviation was 2.4. So the girls' data is not deviating as much as what the boys' data is. And that can kind of tell us that like the range of values for boys is a lot wider than the range of values for girls, right? Because this one has a higher standard deviation than this one. So the girls are a lot closer together in height than the boys are. That can kind of give us those conclusions. Okay, so now you guys have another sheet of paper that's gonna break down some things on here, and I'm gonna do a couple of these with you just to get you started, to kind of show you what I'm talking about. So number 1, you go ahead and answer the question for number 1. Is it a survey, experiment, or observational study when we collected that data? And then it says, what proportion of students are over 5 foot 6 inches tall? Okay. 5'6" is 66 inches tall, if you convert that to all in inches. And that's one thing that I had to do up here was when you guys wrote these down, like 5 foot 6 inches, whatever, I had to convert those all to just inches. Otherwise, I would not be able to calculate the average and the standard deviation very well. It would be kind of messy. So I did just convert those all to inches. So what proportion of students are over 5 foot 6 inches tall? So what I want you to do when you're answering this question, so 2 and 4 and 6 are all asking those same questions. Like what proportion of students are blah, blah, blah. Over this much, less than this much, whatever. So 2, 4, and 6 are going to be those same type of problems. Over 66 inches, let's say if they just say over 66 inches, that's not including 66. So if I go up to this list, I'm going to circle all the people that are over 66 inches tall. And I'm probably maybe going to forget some. So you catch any mistakes that I make. Over 66. These are not over 66. Those are exactly 66. So I will circle all of these. Over 66. We got a lot of ones right in a row that are over 66. And over 70, 66. Okay, there's that one. I'm trying to do this really fast, so I'm not taking up too much of your time. And that's it. Okay, so that is, if I count those up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29 students. I think I got all of them, hopefully. 29 students that are over 66 inches tall, okay? And so for a proportion, that would be 29 out of, we said that there's 60 total students that we did. I think 60. Yeah, 60 total students. And so if it was 30 out of 60, that would be exactly 50%. But let me calculate what that is. 29 out of 60 is exactly like 48.3%. Okay, that's what the percentage is for the proportion over 5 foot 6 inches tall. Okay, now it says if the population of students at Blue Hill is 139, which it is, I looked that up. There's 139 kids that are in 7th through 12th grade. How many would we expect to be over 5 foot 6 inches tall, right? So if 48.3% or 0.483, if we move the decimal, out of 139, we can just multiply those together, and I get like that about 67.2, or somewhere I would say 67 to 68 students would be over 5'6" tall out of this 139. Okay, so 67 to 68 students are over that amount. Okay, so that's what I'm asking for, like on number 3. So 4 and 6 are going to be similar to that. Number 8, it says we sampled 60 students in order to collect our data. What is the margin of error? Okay, so what I want you to do is, for margin of error, I'm not going to do this one for you, but I'll write down the formula. Margin of error is 1 over the square root of n, and then you take that times 100, and you're going to get a percentage, okay? So whatever percent, okay? And that's going to tell you your margin of error. But then number 9 says, 9 goes back to number 2, where it says, if we know that 48.3% are over 5'6" tall, 48.3%, okay? My margin of error is going to tell me how far off that number is. So if it was 48.3, with a margin of error or of whatever, like what two numbers should it actually between? And we add the margin of error, we add the error and subtract the error to get the two numbers that actually should fall between. Okay, so what range of percentage should actually be between 5 and 6 inches, or 5'6" tall? Okay, and so you'll do the same thing for number 10 and number 11. Those will go with number 4 and number 6, that stuff. Okay, so hopefully that makes a little bit of sense. You'll have to go through and count those people that are over or less than or whatever, what it's supposed to be. Okay, on to the back side, this data right here is going to be what is on that front page. So all boys in your sample, we're talking about just the boys, the average and the standard deviation. Average is X bar, standard deviation is S. And those numbers are going to come off of the front side. I'm going to fill in just these two. All students total. I remember the standard deviation was 4.0 for all students total, but let me go to the average. Here we go. Average for all students total was 66.5 and a standard deviation of 4.0. So you go back and you find what these 66.5, what did I just say? 66.5, yeah, I wrote 66.0 for some reason. So you go back through and you put in those boys for just the boys and the girls, and then what I want you to do is fill in your bell curve, okay? Use the mean and the standard deviation to fill in your bell curve. So I know that 66.5 goes here, and then I'm going to add my standard deviation 3 times and subtract my standard deviation 3 times to find those values, okay? Now, if we remember from the empirical rule, when we're talking about like percentages, like if I look at the way that this is separated out, okay, 34% is between these two, 13.5% is between these two, 2.4% is between these two, and 0.1% is from here on up, okay? So we're talking about, I ask you for the tallest 2.5%. That's going to be anybody taller, this is 2.5% right here, anybody taller than this marking, right? So if you are in the tallest 2.5%, you are more than this unit's tall, okay? So you're going to fill that in and what that is, okay? And then look at our list. Does anybody measure in the tallest 2.5%? I don't know. Maybe they do. And if they do, who are they, okay? Then do also the shortest 2.5%. So from that marking on down, how many inches tall would you have to be if you're in the short 2.5%? And then does anybody from our list fill into that, okay? The next two are going to be calculating z-score, okay? And the z-score is x minus x bar divided by, we usually call this number, this variable s, they call it sigma, but that just means standard deviation. So like x is me, this is my value, and then x bar is the average, and the standard deviation is s, okay? So we want to calculate the z-score for somebody who is 64 inches tall, okay? So 64 inches is going to be like down here, right? 64 is a little less than 66.5. And so if this, z-score is like saying the station that you're at. So if this is a 0 station and this is a -1 station, I don't think 64 inches is going to be all the way to -1. It's going to be like -0 point something, right? and that just tells me where he's at on the number line, okay? And that's my z-score. So figure out using this formula what the z-score is, and then also what the z-score is for 69 inches tall, or 5'9", okay? The last problem I have is we're going to create a double box and whisker plot. And we're going to put them on top of each other so that we can compare them. But here is just the data for the boys, and I went ahead and put those in order for you. So like 60 is the smallest for boys, and 78 is the tallest for boys. So there is that, and then girls is the same way. I put those in order, but you're going to find your 5-number summary for each one. And then what we're going to do is we're going to put our box and whisker plot on here. And so I went ahead and put your little ruler down at the bottom, but boys, like, put his box and whisker plot. Don't draw this yet. You'll have to draw him exact. And then girls, whatever the girls looks like, I don't know. But you'll put one box and whisker plot here using this as your ruler, like this, according to those units. Put your box and whisker plot there, put your box and whisker plot there, and then what you're going to do is you're going to write me one statement that compares these plots. You can put your statement down here if you want to. Just telling me, like, the girls are significantly shorter than the boys, or, you know, like, whatever. You tell me just one thing that you notice about the box and whisker plot that is important, okay? So use that 5-number summary, create your box and whisker plot, and do the rest of those, and that is your homework. There you go. I hope that made sense, and if you have questions tomorrow, go ahead and ask, but hopefully the rest of that is pretty self-explanatory, okay?